In this session also we're going to be discussing a very important function, and it goes by the name of date diff. And it's pretty much similar to the date add function, except for the fact that it does not add states. It simply tells you the difference between two dates itself. Now the syntax of writing the date diff function is that you need to have three arguments placed in the date diff function. The first is the interval, which we, as we discussed in the previous sessions, refer to this table. The date 1 is the first date from which you want to calculate the difference from. The date 2 is the second date to which you want to calculate the difference to. So putting it in practice, I have created up a select query to show you how the date diff function works, and I'm applying it on the paycheck. And my intention is that I want to know that since how much time in years has it passed for that the individual that I have in listed in my data set have been in my company. So the way I've written is that I have selected the appointment date and the today's date using the date function, and I have used the date diff function to calculate the number of years. I've written y because this is what you use for using years as the difference value as an interval. And then I've used the appointment date as the first date and today's date as the second date over here. And when I will run this query, we're going to have three columns presented to us. The first one obviously being the appointment date, that is the date at which the person got appointment, and the second column is the today's date, and this third column represents the difference between these two dates over here. Now it tells me that the years that have passed by since this day to this day is 2, and so on so forth for other values. But it's but any questioning mind would think that this might be an incorrect answer, or maybe this is merely an approximation, because since the person who was got appointed on 9th of February 2012, and how could he simply spend 2 years since that date, because 2 years from this date is 9th of February 2014, and today's date is 19th of July, and it could not be 2 years, it has to be more than 2 years. And it's not just for not just this for this row itself. If you move on to the second row, a person got appointed on 12th of December 2013, and it's showing me that from that date to today's date 1 year has passed. This has to be an approximation, any mind would guess, but it is not. This is not an approximation, it is an accurate answer that MS Access is giving to you. The answer lies in understanding how MS Access is calculating the differences between these two dates. So it doesn't really calculate the number of days between these two dates and divide by 365. It simply counts how many calendar years have changed since this date changed to this. So imagining that you have a 9th of February 2012 on your calendar. So how many calendar shifts would have taken to reach today's date? Just two. So 2012, when it changed to 2013, that was the first calendar shift, and when it changed to 2014, it was the second calendar shift. And this is what it is being represented over here. These formulas, dative formulas, only calculate the number of calendar shifts that took place between two certain dates and not the actual dates itself. So if you have one of the appointment dates as 31st of December 2013, and if today's date would have been 1st of January 2014, still the date diff function would have told you that it has the difference between these two dates is 1 year, because there has been one calendar shift. And this is not just the phenomena for the year interval. If I were to change this thing to months also, say beforehand, let's change it to quarters and try running this whole query again, you're gonna again see the difference. I think the difference would be pretty much apparent in this. So 12th of December was in the last quarter of 2013, and 19th of July falls in the third quarter of 2014. So count the number of calendar shifts that have the quarter shift that have happened since this date. So the first the first quarter shift would have came when it passed from 31st December to 1st January. So that was the first one. The second calendar shift would have been when it passed from 31st March to 1st April. So that would be your second quarter shift. The third one was when it changed from 30th June to 1st July. So that is the reason you see 3 as an answer over here. It is not calculating the difference between these two dates and dividing it by 90 days. It is simply calculating the number of quarter shifts that have occurred between these two. And the answer, it could not be best justified if we don't look at this row itself. Now, this represents that the appointment date was 30th of June 2014 and today's date is 19th of July. So although the difference between these two dates is merely 19 days, still it is showing me that one quarter has passed since this date changed to this. And the only plausible way of answering this question is that MS Access is counting the number of quarter shifts that have taken place in that time. The same kind of logic holds for the months also, for the day of the year, for the weekdays, for weeks, for hours, minutes, and seconds. It's just going to count the number of shifts that have taken place. Now, date add and the date diff function are the most widely used functions whenever you have a date value in your MS Access SQL environment. And just a word of caution over here that whenever you're using the date diff function, always remember the logical argument that we have had in this session at length, that it is only going to count the number of calendar shifts that have taken place in that interval. So I guess these two sessions on date add and date diff must have enlightened you on a lot of other factors. I hope you enjoyed the sessions. Thank you for watching.